Hello, students. These are topic tests that we at Bodhee Prep have prepared for you. These tests are designed so that once you go through a concept, you can give this test and see how well that topic is prepared for you in terms of the exam. Once you give a test, you can go through this video where we give a perspective of what could have been a decent attempt, which questions you could have looked at, why you should have left a question, the time that is required for a question, and the overall analysis. If you like the test, if you find it useful, there are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. Just download the app and make use of these tests to help your preparation. This video is for the topic time, speed, distance, test number 2 as mentioned in the app. Overall, this test I'd say was moderate to high level of difficulty, and an attempt of 5 to 6 questions will actually get you a 95 odd percentile in this test. The time taken again because of calculations would be around 22 to 25 minutes overall for the entire test. Moving on question wise, the first question says, P and Q are two opposite ends of a straight running track. Ria and Tia start running towards each other from P and Q. So this is P, this is Q. Ria and Tia start running. Ria and Tia start towards each other from P and Q respectively. R, T. As soon as one of them reaches an end, she turns back and starts running towards the other end. The first meeting happens at a point 210 meters away from P, and the second meeting happens at a point 150 meters away from Q. If the speeds of Ria and T are x and y such that 2x is greater than y is greater than x, therefore Ti is faster than Ria, y is greater than x, y is greater than x, then what is the distance between P and Q? So what we can do here is, suppose the first meeting, like it is given that the first meeting happens at a distance of 210 meters from P. So Ria has covered 210 meters. Suppose Tia has covered X. Therefore, the distance between P and Q is 210 plus X. And in the same time, from the start till the meeting point, the ratio of distance covered by Ria and Tia is 210 upon X. This will be the ratio of speed as well because the time is same. From the meeting point, Ria goes on to Q and comes back. Tia goes to P and comes back. Now suppose they meet somewhere here. This is at a distance of 150 from Q. Since the total distance was 210 plus X, out of that this is 150. So we can say from P to the second meeting point, the distance is 60 plus X, 210 plus X minus 150. This distance was 210. This distance is X. First meeting point to Q, first meeting point to P. Now, from the first meeting to the second meeting point, again, the time traveled by both of them is same. The distance traveled by Ria. Ria was going towards Q will be X plus 150. X plus 150. That by Tia will be 210 from meeting point to P and then 60 plus X. 210 plus 60 is 270 plus X. The ratio of speed of Ria and Tia will be constant. So we get an equation in X, which will solve to get the value of X, cross multiply 210 into 270 plus 210x is equal to x squared plus 150x. X squared 210, 150 minus 60x minus 210 into 270 is equal to 0. These two numbers have a difference of 16. The product obviously is the numbers. So x minus 270 into x plus 210 will be 0. So x minus 270 is 0 or x plus 210 is 0. This will give us a negative value. We don't need that. And therefore, x is equal to 270 becomes the value of x. So that the distance between P and Q is 210 plus 270, which is 480. Option B. Again, the concept is something that you would have done if you've practiced questions on TSD. The calculation might take a bit of time, and therefore I'm saying a moderate level of question could take up to 2.5 minutes. If you've done questions like this before, definitely go for the question. Otherwise, a call can be taken on the question. A train started at 9 a.m. at station X with a speed of 72 kilometers per hour. After 2 hours, another train started at station Y towards X with a speed of 90 kilometers per hour. The two trains are expected to reach each other at 1:30 p.m. Owing to a signal problem arising at 12 noon, the speed of each of them was reduced by the same quantity and they crossed each other at 4:30 p.m. What is the new speed of the train that started from X? Okay, so a train started from X at 9 a.m. 9 a.m. X, a train starts from here. The speed is 72 kilometers per hour. After 2 hours, it will reach some distance. So this is 11 a.m. This is the time when the other train starts from here at 90 kilometers per hour. They are expected to meet at 1:30. But that does not happen at 12 noon. The speed reduces. At 12 noon, the speed reduces by the same quantity. So from here, we can say that the speed of the first train is 72 minus x and that of the second train is 90 minus x. And therefore, the meeting actually happens at 4:30. They were supposed to meet at 1:30, they met at 4:30. Now, from 12 to 1:30, time is 1.5 hours. From 12 to 4:30, time is 4.5 hours. So we can say that time taken is 3 times. Time taken to meet is 3 times of what should have been taken. And therefore, we can say that the speed becomes one-third of what it was initially. Initially, the relative speed of these two trains was 72 plus 90. Now it has become one-third of that. So one-third of this will be the new relative speed, which will be 72 minus x plus 90 minus x. Since the trains are moving towards each other, the relative speed will get added. Since time taken after 12 o'clock is 3 times of what was required, that means speed after 12 o'clock is one-third of what should have happened. The speed was 72 plus 90. Now it is 72 minus x plus 90 minus x. New speed is one-third of the original speed. Why minus x? Because the speed reduced by the same quantity. From here we can get the value of x. 162. 162 by 3, 6, 7, 8, 9 is equal to 162 minus 2x. So this becomes 54. 162 minus 2x. 2x is equal to 108. X is equal to 54. And therefore, the new speed of the train that started from x, new speed is 72 minus x, which is 72 minus 54, which is 18 kilometers per hour. 18 becomes the answer. In terms of level of difficulty, I'd say a moderate level of difficulty question. Calculations are not very high, but conceptually you'll have to understand which proportionality that you're looking at. Once that is figured out, should not take about 2 minutes to solve the question. A and B are the two opposite ends of a swimming pool and the distance between them is 420 meters. Ankur and Manu start swimming. A and B, two opposite ends. Ankur and Manu start swimming towards each other at the same rate. At the same time from A and B. The speeds are in the ratio 5:9. So Ankur and Manu speeds are in the ratio 5:9. As soon as any of them reaches an end, he turns back and starts swimming towards the other end. At what distance in meters from A will they meet? When Manu is in his 13th round, note A to B is considered one round, B to A is another round. Now, if Manu is in 13th round, Manu would have completed 12 rounds and started the next round. When Manu completes 12 rounds, how many rounds will Ankur complete? Since the ratio of speeds is 5:9, whenever Ankur does 5 rounds, Manu will do 9 rounds. If Manu has done 12 rounds, we can say Ankur upon Manu is in the ratio 5:9. If Ankur does x, Manu does 12, we find the value of x. So this becomes 3, 4, 20 by 3. The value of x. 20 by 3 means 6 full rounds and 2/3 of a round. So when Manu has done 12 rounds, so Ankur starts from here, Manu starts from here. 12 round means 1, he will reach A, 2, he will be back to B. 3A, 4, he'll be back to B. So odd number of rounds means he's at A, even number of rounds means he's at B. So the 12th round for Manu will end here. For Ankur, 6 rounds have to be completed. So 1, 2, 3, 4, 5, 6 will be back at 6. And 6 rounds completed here. And then 2/3 of a round. Because the distance between A and B is 420, 2/3 of 420 will be 280. So when Manu finishes his 12th round, Ankur is at a distance of 280 meters from A. Now they start moving towards each other. 140 distance is there. This distance has to be covered and the ratio of speed is 5:9. So we divide 140 in the ratio 5:9, comes out to 50 and 90. Therefore, when they meet at some point, Ankur from here will cover 50 meters, Manu from B will cover 90 meters. And this will be the meeting that they will have when Manu is in his 13th round. What is the distance of Ankur from A? 280 initially plus 50 now, that is 330. Option B becomes the answer. In terms of level of difficulty, I'd say this is a moderate, maybe moderate to difficult sort of a question. 2.5 minutes should be the ideal solving time. In a 5-kilometer race, Rajesh beats Thomas by 30 seconds. Thomas beats Prasad by 70 seconds. If speed of Rajesh is 30 kilometers per hour, by what distance in meters did Thomas beat Prasad? So when Rajesh reaches the end point, at this point, Thomas is 30 seconds behind. And when Thomas reaches the end point, at this point, Prasad is 70 seconds behind. Speed of the race is 5-kilometer race. Now, if we look at the time difference between Rajesh and Prasad, that will be 30 plus 70 seconds, that is 100 seconds. So when Rajesh reaches the end point, Prasad will take another 100 seconds to reach. Speed of Rajesh is 30 kilometers per hour. Therefore, Rajesh will do 5 kilometers in 5 by 30 hours, which is 1/6 of an hour into 60, so 10 minutes. So Rajesh finishes the race in 10 minutes. Rajesh finishes the race in 10 minutes, distance upon speed, or 600 seconds. Thomas therefore takes 630 seconds. 630 seconds. And Prasad takes 700 seconds. The question is, by what distance did Thomas beat Prasad? Now, from here we can say that ratio of speed of Thomas and Prasad will be inverse the ratio of time to do the same distance. Thomas does a distance in 630 seconds, Prasad does it in 70 seconds. Therefore, ratio of speed will be 700 is to 630 divided by 70. This will be 10:9. And therefore, ratio of speed of Thomas and Prasad is 10:9. To complete the race, Prasad has to run 5,000 meters. So what is the distance that Thomas has to run 5,000 meters to finish the race? So what is the distance that Prasad will have to run? From here, we can say that ratio of speed is 10:9. So in this time that Thomas runs 5,000 meters, Prasad runs X. This will also be equal to the ratio of their speeds because the time is same. And therefore, we can write X is equal to 5,000 into 9 by 10, which becomes 4,500. And therefore, when Thomas finishes the race, Prasad has run 4,500 meters, and therefore Thomas beats Prasad by 5,000 minus 4,500, which is 500 meters becomes the answer. In terms of level of difficulty, it's a definitely a moderate level of difficulty question. Solving time could also reach 2.5 to 3 minutes if you're not able to get the right numbers or the right entry into the question. Two persons A and B started running along a 400-meter track. For the first 100 meters of the track, both A and B ran at the same speed. For the next 100 meters, A ran at twice the speed of B. For the next 200 meters, B ran at thrice the speed of A. And for the last 80 meters, A ran at 4 times the speed of B. If B ran at a constant speed of 2 meters per second. 100, 100, 100, 100. No, sorry, 100. Next 100. Next 120. And for the last meters, this is the division of 400 meters. As far as B is concerned, B is running 400 meters at 2 meters per second. So therefore, will take 2 seconds. So speed of B is 2, 2, 2, and 2. Speed of A is different. For the first 100 meters, A and B run at the same speed. So speed of A here is also 2 meters per second. For the next 100, A runs at twice the speed of B. So here the speed of A becomes twice of 2, that is 4. For the next 120 meters, B ran at a speed at thrice the speed of A. So A's speed was 1/3 of B. So here speed will become 2 by 3. 2 by 3 into 3 is 2. And for the last 80 meters, A ran at 4 times the speed of B. So 2 into 4 is 8. Time taken by A therefore will be first 100 at the speed of 2, second 100 at a speed of 4, next 120 at a speed of 2 by 3 meters per second, last 80 at a speed of 8. This is 50 plus 25 plus 180 plus 80. So this becomes 260, 310, 335. This is 10, not 80, sorry. 80 by 8 is not 80, it is 10. Yes, this is the time taken. So 180 plus 10, 190, 190 plus 50, 240, and 25, 265. And therefore, B takes 200 seconds, A takes 265 seconds. What is the difference between the times by A and B to complete the race? Option D becomes the answer. I'd say this is a pretty easy question. Should not take more than maybe 1.5 minutes to solve. Just put in the values and get the answer. In a race, Mohan beats Sohan by 24 meters. Mohan beats Sohan by 24 meters. Sohan beats Rohan. Sohan beats Rohan by 100 meters. If Mohan beat Rohan by 120, Rohan by 120, 120, this is Rohan. So when Mohan finishes the race, Sohan is 24 meters behind, Rohan is 120 meters behind Mohan. When Sohan finishes the race, Rohan is 100 meters behind Rohan. Now, if we consider these two uh, uh, cases, from here to here, Sohan has run a distance of 24 meters. And from here to here, case 1 to case 2, Rohan has run a distance of, Rohan was 120 meters behind. Now only 100 meters behind the finishing line. So Rohan has run 20 meters. Therefore, we can say the ratio of speed of Sohan and Rohan is 24 is to 20. In the same time, from point 1 to point 2, Sohan is running 24, Rohan is running 20. So ratio of speed 24 into 20. When Sohan finishes the race, the difference between Sohan and Rohan is 100 meters. Here the difference is 4. To make 4 into 100, I have to multiply by 25. So we can say 24 into 20 is to 20 should be multiplied by 25. We will get 24 into 25 is 600. 20 into 25 is 500. So when Sohan runs 600 meters, Rohan is 100 meters behind, that is 500 meters. And that is the end of the race. So Sohan has run 600 meters and that will be the length of the race. Again, you would have at least, we would have come across questions like these while practicing. So I'd say easy to moderate question should not take more than 90 odd seconds. We could also use the variable and we could say in the first case, if the length of the race is x. In the first case, Sohan is running x minus 24 meters. Rohan is running x minus 120. So this becomes the ratio of their speeds. In the second case, Sohan is running x, Rohan is running x minus 100. The ratio of speed of Sohan and Rohan has to be the same. So x minus 24 upon x minus 120 is equal to x upon x minus 100. Solve for x, you will still get the answer. Himanshu, Saral, Vikas start running from the same point in the same direction along a straight line at 7, 8 and 10. Himanshu, Saral, Vikas, 7, 8 and 10 AM. Speeds are 2, 3 and 4. When Saral catches Himanshu, he sends Himanshu back immediately to deliver a message to Vikas. At what time would Himanshu meet Vikas? So first let us make Himanshu and Saral meet. Saral left after 1 hour, after one hour after Himanshu left. So if Himanshu has traveled for X hours when they meet, Saral would have traveled for X minus 1 hour less than Himanshu. Also, both of them, this is time, both of them would have covered the same distance because they started from the same point and they are meeting. So the distance covered will be same. Distance for Himanshu will be speed of 2 into time of travel x. Saral will be speed of 2 into time of travel x minus 1. Since distance is same, we can say 2x is equal to 3 into x minus 1. So 2x is equal to 3x minus 3 or x is equal to 3. So 3 hours after 7, after Himanshu started, that is at 10 o'clock, Himanshu and Saral will be at the same place, and the distance they would have covered from the starting point will be speed of 2 and time of 3 hours, so 6 kilometer distance would have been traveled. At this point, Vikas starts to travel at 10 o'clock, and that is exactly when they are meeting. The Himanshu and Saral are meeting. Sends back Himanshu to deliver a message to Vikas. At what time would Himanshu and Vikas meet? Now the difference or the distance between Vikas and Himanshu is 6 kilometers that Himanshu has traveled. Relative speed here will be, because both of them are traveling towards each other, speed of Vikas is 4, speed of Himanshu is 2. So the relative speed will be 4 plus 2, which is 6 kilometers per hour. At what time will Himanshu beat Vikas? So time taken will be distance upon relative speed, which is 1 hour. This Himanshu starts to travel towards Vikas at 10 o'clock. After 1 hour, that is at 11 o'clock, 11 a.m., Himanshu and Vikas will end up meeting. Again, maybe easy to moderate sort of a question. If you look at previous CAT questions, there was a question that was very similar, but I think of a higher level of difficulty than this. So maybe 2 odd minutes to solve the question. For me, easy to moderate. A train started 9 a.m. at station X with speed 72. After 2 hours, another train started from station Y towards X at a speed of 90. The two trains are expected to cross each other at 1:30 p.m. Owing to a signal problem at 12, the speed of the trains reduced by the same quantity. They crossed each other at 4:30 p.m. If the signal problem had occurred at 1 p.m. instead of 12, at what time would the trains have crossed each other? Again, there are two trains at 12 o'clock. They're at such a distance that they will meet in the next. This is 72. This is 90. At this point, the speed reduces by the same amount, and they were supposed to meet at 1:30. Instead of that, they meet at 4:30. So instead, from 12 to 1:30 is 1.5 hours. From 12 to 4:30 is 4.5 hours. So we can say that time after signal problem becomes 3 times. Now, if the problem does not occur at 12 but occurs at 1, the actual meeting time or the normal meeting time after 1, normal time after 1 will be from 1 to 1:30, which is 0.5 hour. But we know that time after problem becomes 3 times because the speed reduces. So new time after 1 or new time taken after 1 o'clock will be 3 times of 0.5, which is 1.5 hours. 1.5 hours after 1 is nothing but 2.5 or 2:30 p.m. So if this problem had occurred at 1 o'clock, instead of half an hour, they'll take 1.5 hours to meet. So they'll meet at 2:30 p.m. Again, a moderate level of question. This was a part of something that we did earlier in the test as well. If I compare this and that question, this would be even more easier because here no calculation is required. Only proportionality will give us the answer. A man has a special rechargeable electrical vehicle which can maintain a speed of x kilometers per hour for 100 minus x minutes, after which it has to be recharged. What is the maximum distance that the van can cover on the vehicle without charging in between? Now, distance is nothing but speed into time. Speed is x. Time is 100 minus x upon 60. Because this is in minutes, we convert it into hours. So this becomes, we have to find the maximum distance. This becomes 100x minus x square upon 60. So basically, we have to maximize this. We can write it as 2500 minus 2500 plus 100x minus x. So I'm trying to complete the square. Here we had a term x square and a 100x. 100x we are splitting as 2 into x. Remaining part is 50. So we need the square of 50. I've added and subtracted the square of 50, which is 2500. So 2500, taking out the minus. Here we get x square minus 100x minus 2500. This will be plus. Upon 60. This becomes 2500 minus x minus 50 whole squared upon 60. $2,500 upon 60. Oh, sorry, this is a square. This has to be plus. This has to be plus because it is a square minus 2ab plus b square. So we get the minus 2500 in the bracket, so 25 remain outside. This becomes x minus 50 square. Now, the maximum value of this will be when the negative term is minimum, and the minimum value that a square can take is 0. So when x is equal to 50, this term becomes 0 and the maximum distance we'll get is 25 by 60, which will be 250 by 60 or 125 by 3 or 41 2 by 3. The maximum distance in kilometers it can be covered is 41 2 by 3. In terms of level of difficulty, I'd say moderate to difficult, and as long as you're not comfortable maximizing the square, this might actually be difficult. Solving time probably 2.5 minutes for this question. Yamini and Zora are standing 25 kilometers apart. Zora starts moving towards Yamini. Yamini, Zora, 25 kilometers apart. After 40 minutes, Zora starts moving towards Yamini. After 40 minutes, Yamini also starts moving towards Zora. By the time Yamini covers 5 kilometers, Zora has covered 15. So when Yamini covers 5 kilometers, Zora has covered 15 kilometers. We cannot say the speed is 1:3 because Zora started earlier and therefore the time is not same. They meet at a point 7 kilometers from the starting point of Yamini. What is the speed of Yamini? The meeting point is 7 kilometers and therefore Zora here has covered 18 kilometers. Now there was a time, say T1, where Yamini had covered 5 kilometers, Zora had covered 15 kilometers. From this, after this point, both of them are walking, and at T2, Yamini has covered 7 kilometers which means Zora has covered 18 kilometers. If we compare these two, we can see that the time in which Yamini covers 2 kilometers, Zora covers 3 kilometers. So the ratio of their speed is 2:3 because in the same time, one is covering 2 kilometers, the other is covering 3 kilometers. We have to find out the speed of Yamini. Now, using this, if we find out what is the distance covered by Zora when Yamini covers 5 kilometers, because the ratio of speed of Yamini and Zora is 2 by 3. In the time that Yamini had covered 5 kilometers, Zora say covered X kilometers, so the value of X will be 15 by 2. But it says by the time Yamini covered 15, Yamini did 5, Zora had done 15 kilometers. That is because Zora walked for 40 minutes extra, which means in the time that Yamini covered 5, Zora covered 15 by 2. So the remaining, that is 15 minus 15 by 2, which is 15 by 2. Half of this would have been covered in the first 40 minutes. So basically, Zora covered 15 by 2 kilometers in 40 minutes. And then at that point, Yamini also started walking. And Zora covered another 15 by 2, in which time Yamini covered 5. And therefore, total, Zora had walked 15, Yamini had walked 5. So we can say speed of Zora is 15 by 2 kilometers in 40 minutes or 40 by 60 hours. This becomes kilometers per hour. 15 by 2 into 60 by 40, 0, 3, 2, 45 by 4 kilometers per hour. This is the speed of Zora. We know that the ratio of speed of Yamini and Zora is 2:3. Therefore, speed of Yamini will be 2/3 of speed of Zora, which is 45 by 4, 15 to 7.5 kilometers per hour. So speed of Yamini is 7.5 kilometers per hour. Again, this question would probably be a moderate sort of a question. Attempt time clearly has gone beyond 2 minutes. 2.5 minutes should be good enough to attempt this question. Not necessarily a question that you look at doing directly in an exam. Better if you have attempted such a question earlier. If you look at the overall paper or the test, as I said, overall level of difficulty for me was moderate to difficult, and in this test, 5 to 6 questions will definitely give you a 90 to 95 percentile net correct. If I had to choose these questions, the 6 questions or 5 questions, my choice will be 1, 3, 4, 5, 6, 7. Which are these? Would have done this because I've done questions like this earlier. This is a new question. Only if you are able to see the proportionality, go for it. Would have done this because I've done this earlier. This, I think, is a time-consuming question. And if there is a good chance that we might get confused with the numbers. Would have done this. This was one of the easier questions in the set. Would have done this because, again, I've done similar questions earlier. This also I thought was an easy question amongst the questions that we had. This is related to 2. If 2 is happening, is it 8 is happening and vice versa? Again, 9, if you are someone who knows quadratic equation, can be attempted. And then 10. I am saying I would have chosen 1, 2, 3, 5, 6, 7. So 2, 8, the ones that were connected. I'm leaving out 9 because quadratic is something that all of us would be comfortable at this point. And the 10th question I thought was a decent question, not the easier one. So my attempt will be 1, 3, 4, 5, 6, 7.